Okay, so today's date is the 14th of February 2026. The time now is 6 30 p.m. So literally, I've got this was gonna work out in the way I want it to work out. But um, this video is focused on context switching. So I'm on the blackboard in the ward, but let's see how we do. So we're on the blackboard in the ward, yeah. So the blackboard in the ward, so it's gonna be fine to continue. But context switching. What is the context switch? A context switch, basically, you got 3 pointers. Yes, no, and maybe. Because I go yes point now. Yes, yes, one. True. Zero. No. Maybe -1. Maybe -1. The -1 part holds to resolve the state of the consensus via the exposure from e to the power of -1 is e's can be e is a special variable to the power to the power of -1 b okay, e to the power of -1 b 0.3678. This is really a maybe flag of our system. E to the power 1 is 1. E to the power 1 is 0. E to the power of 1 is 0. E to the power of 1 is 0. So e to the power of 1 is 0. Basically, e to the power of 1 is the same number. So you go to e to the power of 0 is 1, basically. E to the power of 0 is 1. So any natural number, but it goes to have here the context switch. So context switch basically switch between context. Basically, I'm going to show you the implementation in the other board on the chalkboard here, but it's context switch. Context switch basically. So you get a tokenizer. The tools can have in true interpretations for yes, no, or maybe. Tokens can have a symbolic interpretation of Alexa. So what do tokens mean at 3 stages? And it goes to have these are called poles. So, like example, if you have var x equals 2, var x equals 25. Oh, what's my pen? 1 second, guys. I can't find my pen here. Oh, I can't find my pen. What gives you my pen? Sorry, guys. My pen is here somewhere. You know. Yes. So, I'm saying to research as well as I had to report. So, I'll write on the board. So, show what so, so you're gonna have system of interpretation. I've got a pen and so, goodness, okay, here. So, I found my pen right now. So, I'm saying to you, we have a system of interpretation. So you're gonna have this to work properly. So you're gonna have a symbolic interpreter, which can prove itself. So a symbolic interpreter basically can prove itself, but the working dimension, you have to measure the dimension of sense. So for you have to have sense in dimension. So you can't get arbitrary measure of a human. You can't take a sense information of it. So you can have yes, no, and maybe. You can have Alexa that categorizes a statement in yes, no, and maybe over interpretation. So, for example, yes would be, for example, this is a true yes, true false, true or false. This is a statement is true or false, and or no. Expression expresses a model. Expression is basically the end result, the model of the sub. The model is tripartite. Tripartite. This just means there's 3 representations of the model. But the system must show that the system can be conditional. So we understand the polls. So the polls are yes, no, maybe. So I'm saying I'm trying to build an engine that has 3 models of beer concept system. So tripartite model because either yes, true, false, and maybe. True, false, and maybe. You have yes, three models that result to that state of engines. And basically, the system has to resolve itself. So the statement is true or false. True, false, and maybe, and the expression is to the opposition or the how the model looks based on the statement is tripartite. Which you have 3 representations of a system, 3 interpretations of the same system. Mathematically, I can't really formalize this. But mathematically, you're gonna have for var x equals 2, var y equals 2 times I, two times x, two times x, so 2 times x, 2 times x, 2 times x, minus I. So you're gonna have y equals 2 times x minus I. Try to get I equals 0, var equals 0. No, I think it's okay. So I equals I equals um I equals um var I equals 0. So no, no. Let's remove the I here. The I'm saying to you, the basically can basically I'm trying to give you something else instruction. So I'm gonna try to call this video probably, so I'm gonna have a quality format, because I'm stating that the way this integration works, tripartite is equally quadratic. So if you have like a var x equals 5, var y equals 5 6 6 6 times x squared, no, var a equals 5, y equals 1, a squared is b1, so it's a squared, y. So basically, let me start again. Let me start again. But this is the thing on the engine system. The consequences, you're gonna have var a equals 15. Var b var x equals 12, 12, 12, var x equals 12. Var b var b equals minus 13. Var y equals 12. Var c equals 13. Var c equals 13. So, this basically is a linear set of instructions that are on the board, but they are not good enough to resolve the system. They are variables that are really isomorphic. So if you look at the function ax squared plus by plus c equals 16 equals 16 equals 16. Let me see. So you're gonna have equals 16. C equals 16. Plus C plus C. C is 13. Equals 16. Okay, the equals 16. So you can have 15. 15. 15 times 15 times 12 squared, or 144, plus minus 13 times y, 13, 12 plus 13 equals 16. Basically, this is a quadratic formula, but it has an exponential law. So because what I'm trying to do today is give you the y the quantity so much. So you can have this reduced. Basically, you have you can either you can either do this top down or bottom. You can do LR AR parsing, which is like a top down parsing. But I'm trying to do a shift reduce pattern. So shift reduce pattern will basically be using given this as a polynomial. This is a polynomial term, and this is evaluated as a structure. So the context switch will switch to context between the whatever is done, bottom up, to give you results. So this is equivalent to writing, to defining a structure like a a structure like an in-memory structure that's not a structure, a structure. No, like basically the goal things for this. this could, a var block, a var ABC equals uh, uh, var A equals var A equals 15. B, comma B equals minus 13, and C plus C equals 13. C equals 13. This var block is basically a scoped function, but you can have so these terms are polynomial and a simple question. But basically this statement var x interdependent of each other, but you used to have them parsed as a root, so it doesn't rotate. So you have them rotate. But the question point shows that the system resolved in context. So you can have them operating on different aspects of space. So you can have same thing var round bracket x equals 12, y equals 12, and and you can get x and y. So x and y are points, and you get x, y, and c. You can get var c. Uh, uh, yeah, so you can get so you get these two var blocks. These two var blocks. So you're gonna have them scored. So you see the blocks of memory. They're heterogeneous model, the homogeneous model. They have the same type here, but they can be heterogeneous, homogeneous depending on the details put in there. But the var blocks is something that's crucial to one problem. Because so I have to give you an engine model here, and why this matters. So look at the board now, guys. If you want to follow on, but if I remember this properly, I hope I'm doing this right. So I'm saying to you, you're gonna have this model here. So I'm going to have the emulation, the C emulation power structure. You can define an atom, as a hydrogen atom. But hydrogen is basically 2H. They're together, they bond together. So you know, see, this is one hydrogen atom. It's not really so 2H, 2H. So basically, two hydrogen atoms come together. So this is like a struct of an atom. This hydrogen, but the atom hydrogen. You see, it's struct, but then the atom, the color process, and you got an empty space here. But the atom has properties. So, and the properties are what constitutes the system. The constitutes of what constitutes. You're gonna have properties on the data or the data. So if you go to the github.com /OB nexus D for Delta, F Oscar, P for Papa, dash, DOP, dash, adapter, is alpha, B for beta, is alpha, P for Papa, alpha. This is object order programming and object order programming and function programming. So the functions are pointed to data. But you have to define this. So the real world is an object model. So this one matters. The world is not an engine. The world is an object. Everything you see in is physical. Nothing is unphysical. So that's why it matters. So the context function runs functions at the time you use one function. You execute by need. It's more of an execution logic by need. So basically, this object is invocable via context, and because they have functions are objects too. Because they have object isomorphism in the state, but the objects are basically extendable, classifiable. What the thing I'm saying is that they have so if you have a hydrogen atom, you can have a position of velocity of atom. You can extend that later to more properties in a different class. You don't have to bind you have to just register system to the symbol table, of the system, symbol table. So the symbol table will extend it, and you can run more code, more functionality in the object overall. And this is a polyglothic. So the data is the total and object model. The presentation of the system is isomorphic as well. For example, I have one here. Runnable code, runnable. So runnable. So you can have things that are runnable. This is a property. So electron has a spin. Electron has a spin. Photon has a spin. So the spin will be position of velocity. Spin. So electron has spin a half. Spin a quarter, but it's called the electron spin around the nucleus. You can define them as protein, but the purpose of namespace. So namespace ensures electron spin. I used the word spinning system. It's the word spinning a half. It's the spinning what? It is spin a half. spin to 5 to 0 or 1 equal or 2 or 1 to 1. Because the code is spin or runnable. Runnable, it's in the spin. Proton or spin, proton neutron, proton, the shape state proton neutron, and then you have proton neutron, hydrogen. For example, you're gonna have two pairs of hydrogen, H2 plus O2 equals H2O2. And this will give you kind of the model of water. So you're making water here. But you're going to have two water here. So you can have the object spin at a time, space and time, and have some result in that kind of telemetry system. So, via the triangle pair, to see what's going to happen, what stands for with the triangle pair model, what the object is spread. But you're going to have, so quantity space determines whether the parts are wrong or the the tokens have been evaluated and the parts are wrong. So you have three yes, no, and maybe. And that's the goal of the project. So I'm sure to make this properly, but the position of listen, let's look at electron can have position of velocity, and they have, we try to measure position, you have to account for the velocity and vice versa, so you kind of have runnable code, executable instrument, and library, so loadable. So the loadable things are the things already in there, but the loadable things are just the object model. So loadable is just that, if they have, if you don't know, if the content minus 1 pointer for maybe you wanna run the loadable code. Minus one, two minus one pointers to the runnable system. But this is between 0 and 1. So it could be you can either have 0 1 based on when they need to pull and what actually to do. The person have some ensure that the library is a library of target program is separated and the strong was secret about itself, as well as via the data or because functions and objects are two in the framework of functional programming. This have different conditions across the runnable, executable. So they all work on pointers, by the way, and that's why it's beautiful. They all work on pointers. So if you have a pointer in a struct, you can have a system of the structure create a pointer again, and and keep the world running. But you go to detach from the ruler in the program aspect and have an object in the system, as a representation of the system. The same. So here. So this is board here. See the guys. Take a picture, you guys. If you want to. That's the board there, but that's the board there. So that's the board. That's my face. Let me see if it's run now. Thank you guys for watching this video. If you like it, share, subscribe. If you don't like it, don't leave it behind.